Right, tonight we're going to be taking a look at Think Central Lesson 113, focus on mathematical practices. So the main goal here is really using the MEAL strategy, model, equation, algorithm, and label your answer, because these are complicated problems that are multi-step. Let's unpack the problem. All of the problems are based off of this, so we'll read it once and we'll come to understand it. Purple martins are birds that nest in colonies. Purple martin birdhouses are sometimes called bird hotels. Suppose a fifth grade class has decided to build a two-story purple martin bird hotel. Each story of the hotel will have 6 identical compartments. One story is shown below. So this is one story, but it's going to be a 2-story high bird hotel. The bird hotel is going to be made of wood, and each story will have the same characteristics and dimensions. So the inside dimension of each compartment, that would be each compartment, one of these is going to be 6.5 by 6.5 by 6.5. So each one is going to be 6.5, 6.5, and then 6.5 tall. So length, width, and height will all equal 6.5 inches. The wood used for the exterior walls, that would be this part right here, is going to be 5/8 inches thick. And the wood used for the interior walls, which would be these here, would be 1/4 inch thick. What is the length of one story? Do not include a floor or ceiling for your calculation. So we're going to need to come up with a model to add this up. Alright, so I've drawn a model to represent this right here, including the dimensions. So each, the exterior wall, 5/8 inches, that would be this right here. This is 6.5 inches here. There's an interior wall, so that's 1/4 inch, 6.5 here. Interior wall, 1/4 inch, 6.5 here. And exterior wall, 5/8 inches. So if I'm able to add up all these dimensions, I will get the length of the bird hotel in inches. Alright, first I'll start off with the inside dimensions for the compartment. So it's 6.5, 6.5, and 6.5. I'm going to add those up. The half, half, and half gives me 1.5. 6, 6, and 6 gives me 18. So it's 18 plus 1.5 inches. That's going to be 19 and 1/2 inches for the length of each box. Next I'll add the dimensions of the length of each exterior wall. So it's 5/8 and 5/8, which is going to give me 10/8, or if you simplify that, it's 1 2/8, or if you simplify that, it's going to be 1 1/4 inch for the exterior wall. So I'm going to go ahead and add that to the 19.5 inches. And finally, I'm going to add up the length of each of the interior walls, and that's 1/4 and 1/4, which is 2/4, which can be simplified to 1/2. So I'm going to add that 1/2 to what I already have, and this is going to give me the total dimension of the length of the bird hotel. So I got a 1/2 inch, a 1/2 inch, and a 1/4 inch. So that would be a 1/2 and 1/2 as a whole, and a 1/4. So that's going to be 1 1/4 inches. And then I'm going to regroup that one hole here. Ends up with 19 plus 1 plus 1. So that's going to be 21. So the total length of this bird hotel, including the walls, is going to be 21 1/4 inch. Alright, so exact same problem. The only difference is they've changed the dimensions of each compartment to 8.5 by 8.5. And they're asking us, what is the height of one story? Well, the height of one story is 8.5. So each story should be 8.5. So we really don't have to do any math on this problem. We don't have to calculate anything. We just have to read the dimension as 8.5 by 8.5 by 8.5. So the height should be 8.5. If for some reason that's not right, go ahead and look at the step-by-step or view example, and that will help you. Alright, back to the same problem we had for the first one, except this time they're asking us for the width. So we're trying to determine this. You can see there's an exterior wall here. There is an exterior wall here, interior wall here, and exterior wall here. So we're going to have to add those up. Also, additional information is each story of the birdhouse creates an overhang of 1 inch in all directions. So we're going to have to add an overhang inch for each story, and it is a 2-story birdhouse, so we're going to have to add 2 inches for each overhang. I've drawn a model of the width right here. You have the 1-inch overhang here, you have the exterior wall, which is 5/8 inches, you have an interior wall, which is 1/4 inch, you have your compartment size, which is 5.5, another compartment size, another exterior wall, another overhang. So we're going to need to add up 1 and 5/8 and 5.5 and 1/4 and another 5.5 and another 5/8 and another 1 to get the total width of the bird hotel. Okay, so adding up the dimensions we have here, we have the overhangs of 1 inch and 1 inch here and here. We have the exterior walls of 5/8 and 5/8 here and here. We have the compartments of 5.5 and 5.5 here. The only other dimension we need to add is the width of the interior wall, which is 1/4 inch. So here, so adding up 1 and 1 gives you 2. 5/8 and 5/8 is 10/8, which simplifies to 1 and 1/4, and 5.5 and 5.5 is 11. So we have 11 plus 2 plus 1 and 1/4 plus 1/4. Putting these, lining them up vertically, you get 1/4 and 1/4, which is 2/4 or 1/2. And you have 2, 1, and 11, which gives you 14. So the total width of the bird hotel should be 14 and 1/2 inches. Let's unpack the last problem for the homework. Purple martins migrate great distances, spending winter in South America and summer in the United States and Canada. A diet of flying insects supplies purple martins with energy they need to complete such long flights. That's kind of just extra information. We really don't need that, but it's good to unpack it anyways. Suppose a purple martin migrates about 4,150 miles to South America each fall and about 4,100 miles back to North America each spring. So just drawing that, you'd have the migration to and then the migration back. Each one of those would be 4,150 miles. Also, suppose purple martin performs this round trip each year for 6 years. They're going to do this 6 times. So you could draw a model, something like that. You could use a 1, 2, 3, 4, 5, and one more. You could do a number line, something like this. You could do a number line to represent each of the 6 years. So it'd be 1 year, 2 year, 3 year, 4 year, 5 year, 6 years, and each one of those would be split into 2 with 4,150 each time. So if we figure out how much they do in 1 year and multiply that times 6, that should give us the total distance. And then on top of that, once we figured that out, they're asking us to compare that to the distance at the equator. So at the equator, the distance around the Earth is 24,900 miles. About how many times around Earth would the purple martin described above fly during the migration? So let's look at this. In the fall, they do 4,150 miles. In the spring, they do 4,150 miles. So together, it would be 4,150 plus 4,150, or 4,150 times 2, and that's going to give you 8,300. So in 1 year, they do 8,300 miles. Next, we'll figure out how far they go in 6 years. So I'm going to take that 8,300 miles and multiply that by 6. You can use a calculator when you do this type of work because it's more about the procedure and the process than the actual answer. But I'm pretty good at multiplication, so I'm just going to do it manually. 6 times 3 is 18. Regroup that. 6 times 8 is 48, plus 1 is 49. So they travel, in those 6 years, they would travel 49,800 miles. And the final part of the problems, they're asking us to compare the distance around the equator, which is here, to how far they travel in those 6 years, which would be here. So if you look at that, you can see that the distance from the equator, is about 25,000, and this is about 50,000. So it is about 2 times, the purple bottom travels around 2 times the distance around the equator in those 6 years' time, because 2 times 24.9 would be 48.9. All right, keep working hard. This is just practice. And the more you practice, the more higher level of mastery you develop. Keep it up, and make sure you keep those questions coming. That is very helpful for the teacher and the student. Thanks.